back. So today we are doing a Leetcode style question, and I am thinking about doing pattern based questions for this series. And it is good to practice common problem solving patterns or look at them because one, they help you build transferable intuition. So once you've internalized the sliding window pattern, for example, you immediately spot it in any new array substring question, even if the exact story or constraints change. So over time, you'll recognize patterns in O1 time. Instead of reinventing your own approach every single time. So that's kind of neat. And the other reason is because in an interview, time is very scarce. When you see a linked list cycle problem, for example, you'll recall fast slow pointers, templates, rather than fumbling through all the possible ideas. And having a small toolbox of go-to strategies just lets you jump to coding much faster. So I've thought, it'll be good for us to practice problems in patterns. So this week we're focusing on the two pointers problems. And if you haven't subscribed already, please don't forget to subscribe so that we can talk more about coding. And yeah, just do some fun Leetcode, I guess. But there are other AI ML videos too. We have series on that as well if you want to go ahead and have a look at that. But let's get started. So this one, given a sorted list of numbers, remove duplicates and return the new length. I'm going to underline a few things as I go. So one thing that I can immediately see that is, it's very important, that it's a sorted list. Okay, remove the duplicates and return the new length. So we're returning the length, we're not returning the list. Okay, you must do this in place and without using extra memory. Okay, so this is in place, otherwise would have been a very easy problem. We could just iterate through the whole thing and create a new array, but it's supposed to be in place. Okay, that sounds good. So if the input is 0 0 1 1 1 2 2, it should output should be 3. Your function should modify the list in place so that the first three elements become 0 1 2 and then you return 3. Okay, that sounds good. And it's saying in place, so of course by default that's O1 extra space, and we have to return the length. That sounds good. So this is a very clear two-pointer problem, and we will have two pointers such as, let's say, fast pointer, let that be our J, and then this is going to, function of this would be to scan every element looking for next new value. And then we have our slow pointer, and that will be, let's say, I, and then the purpose of the slow pointer would be to track the end of unique reason so that we know where to insert next, right? So that means, for example, everything at indices 0 to I is guaranteed unique. Does that make sense? I hope that makes sense. Okay, so we're already thinking about how we're going to scan every element and how we're going to keep track of the unique elements, and that's basically what we need, right? So the core idea here is at the start of each iteration, all values start of each iteration, all values in nums 0 to I are unique elements so far, in sorted order, right? Because our array itself is sorted. And it's nice that it's sorted, because if you look at it, then we know that all the similar or same values are adjacent to each other because it's sorted. So that's really neat. And then I points to the last unique element. Now, this is the most important part. Let me actually keep on showing this. Okay, so when nums I or j, when the fast pointer's value is not equal to the slow pointer value, we have found the next unique element at j, right? For example, I have 0 0 0 1 1, and then my slow pointer is here, my fast pointer is here. If they're not equal, then what does that mean? We found a new unique value, right? So that means what would we have to do at that time? We would have to move the slow pointer to the next element because, like we said, our slow pointer tracks the end of the unique reason. So we're adding one more to the unique reason. So what are we going to do? We're going to move our slow pointer to the next slot. So advance I to the next empty slot, which would be I plus 1, because I currently refers to the last occupied unique index. And then the other thing we would have to do is copy the new value into that slot, right? Because we need our 1 over here at this point. Okay, so then that means nums I, since we've already incremented it and it's in the right place, would be nums j. Does that make sense? Because if we swapped before incrementing, we would overwrite nums I, which is the last unique value, and that would corrupt our unique reason. So we move the pointer and then we swap. That's really the core crux of this algorithm. So we can start writing our code at this point. And I'm going to write in Python. If you prefer something else, please go ahead. But I hope it's easy enough to just understand the code and take it to whichever language you take it to, because it's very simple, nothing very Python-y about the solution. I'm going to take care of the base case here. And if you want, you can always come back and take care of the base case at the end. But do think about the base cases, because I feel like interviewers would prefer that you're thinking about it. So if not nums, return 0, okay? Because it's very simple. I'm just getting it out of the way. Okay, now this is our slope pointer, I equals to 0. And then for j, I'm just going to use for loop, because see how like for j, we're just scanning every element looking for the next new value. So it'll just be easy if I use a for loop. So for j, I'm just going to go with a for loop. For j in range 1 and then len of nums, of course. So if nums j is not equals to nums I, we just talked about this case where these two are not equal, then what do we do when we found the next new unique element? Add this, found next unique element. Okay, so what are we going to do? First of all, we move the slow pointer to next free slot. Okay, so that would be I equals to I plus 1, and then next we would copy the new unique value into that slot. Okay, and that would just be, oops, let me make sure. Okay, nums I equals to nums j, and that's it. That's all you really have. And at the end, we do have to return the length, and at the end of the for loop, so the length would be last unique index plus 1, because indexing is based on 0. That's why, since we're returning the length, we're returning unique index plus 1. And that would just be return I plus 1. And if you're not from Python, these are comments. Anything with a hash is a comment. And that's it. That is our solution. So yeah, this 2-pointer was a very easy problem. We just had one slow pointer, one fast pointer, and then we had to figure this out before starting. So this was the real crux, and since we figured that out, everything else just came very easily. Good luck. Let me know how it goes.